kind of talked about it in environmental science, so I was kind of interested in looking at it a little bit more. And it's relatively new, and I wouldn't call myself an expert on it just because new stuff kind of emerges every day, and some of it's kind of confusing and some of it's kind of hard to like keep track of, but I'll do my best to try to kind of explain some of this stuff. So what is it? Basically, it's just a large-scale intervention with Earth with the intent to reduce the effects of global warming. So it's basically just these crazy scientists who think of ideas and ways to kind of stop global warming in other ways than just like cutting emissions and stuff like that. So it's something that scientists have thought of before, but it wasn't really too popular with people, so it wasn't really talked about until like just now. And some people believe that it can be used in replace of cutting emissions while emissions, just to kind of relieve some pressure that we're facing now, like as we kind of approach this 2 degrees Celsius kind of like marker. So there's different ways people kind of go about it. I'm going to talk about that some more later on. What is it continued? It's like big science's solution to the problem of global warming. And David Keith, who's one of like the major guys on this, says that there's such little progress going on right now globally on the subject of global climate change and limiting global warming that he believes that geoengineering techniques may end up being the solution if we keep kind of going at this like slow rate. So scientists are kind of coming up with these ideas that nobody's really appreciating now, but if we make like such little progress on the other things, then maybe these techniques will end up being what we use. And one of the major upsides to these techniques is they're incredibly cheap, and they're also fast and easy to put into action. So that's kind of just like a basic outline of what geoengineering is as a whole. And there's many types, but there's really two that I wanted to focus on, and one that I really wanted to focus on more in depth. And just to kind of tell you, like none of these have really been put into action, but the first one's cloud reflectivity, which they basically just want to spray seawater onto like lower level clouds, which in turn would make them brighter, just like more white, and this would allow them to reflect more sunlight. And once again, it's really cheap and it has the potential to work, but nobody really knows what would happen because it hasn't been like put to use yet. It's just been done through like lab testing and computer simulations. And there's like plenty of negatives that could potentially happen. The weather could seriously be impacted, and like droughts could occur and stuff like that. So nobody's really sure what could happen with that. But one that's kind of received the most publicity in my research was the sulfate aerosols. And so it seemed to be the most practical and logical solution, and it was the most talked about. So basically what happens is sulfate aerosols are pumped into the stratosphere and the mesosphere, which would ultimately reflect sunlight back into space, which is like an albedo enhancement. And so when the sulfate aerosols are like pumped into the stratosphere, they combine with water vapor to kind of form these like molecules that would reflect the sunlight coming in, which would mean less sunlight, less warming, and like less ice melting because there's just less sunlight. And there was a cool stat. I don't know. No, that's the next slide. So David Keith and other scientists that kind of work on these projects are certain that this type of geoengineering will work because it already happens naturally with volcanoes. And there was, I forget which volcano it was, but in 1991 there was a massive volcano eruption which naturally releases sulfate into the atmosphere, and the globe cooled by like 1 degree Celsius for that entire year just from one volcanic eruption. So David Keith and some of these other scientists think that if we it would cost like $10 billion to put these sulfate aerosols into the earth, and if we do that and we reduce the solar radiation just by 1.8%, but we double the amount of CO2 we use, we could still stay below that 2 degrees Celsius mark. And I don't think anybody's really saying that we should double the amount of CO2, but that was just kind of a stat. Like if we keep up what we're doing, but we reduce the solar radiation, we can still kind of stay below that, that 2 degrees Celsius mark. And another idea that was kind of Keith's own would be to put the sulfate into the mesosphere, because a lot of people have kind of attacked the idea of putting it in the stratosphere because it would have so much effect on our ozone, and having it in the stratosphere also has a serious impact on our weather, which could cause droughts. But Keith suggested if we put it in the mesosphere, that would kind of limit the impact on that. And another thing he said, which I thought was kind of interesting, is that he said that if we use this type of technology and there's so much CO2 in the air, it actually acts as like somewhat of a fertilizer for crops, and there would actually be better crop yield with the amount of like CO2 in the air. It's kind of an interesting thing. But with all this and like so little really being known about it, there's several like overarching negatives. So no one really knows exactly what would happen with these ideas because they've never really been implemented. And another major thing is there's no global governance over this type of technology. So no one really knows exactly what will be agreed upon. Like if we can't even agree upon like cutting back emissions, like who knows what people would think about this kind of crazy technology. And if this type of technology causes the globe to cool, this could actually spark the continuation of combustion. So like if the globe is cooling, we could still be pumping CO2 into the air, which we probably don't want to keep doing. And so like if we start, these are just kind of questions to think about. Like if we start, when would we stop? And if there's like a malfunction in the technology, if there's a malfunction in the pumps pumping the sulfate into the air, but we're still having all this CO2 in the air, like how much could that affect us like with the warming? And like what would the repercussions of that type of malfunction be? We don't really know any like the answers to those questions, so it's kind of a risk just to even consider using this type of technology. And some final thoughts. I think David Keith kind of looked at it like this, and I kind of see it too, is that geoengineering should be looked at more of a way to like take the heat off, because we're coming so close to the 2 degrees Celsius mark. I think it's kind of just a cool way to, like, in addition to cutting emissions and doing all the things that we're supposed to do, if we kind of use this technology, it's a way that we can kind of relax and not have to worry about like so much of like approaching that 2 degree mark. And one interesting point is that some of these techniques are just being started talking about, and it's scary to think how much control we can really have over the Earth if some of these things could work. So these are just like preliminary technologies, and if they kind of develop and scientists actually start putting time into them, it's really kind of scary to think about how much we can really control on Earth. So just to reiterate that there's such slow progress being made globally that these solutions could maybe end up being what we use in the end. And it shouldn't be seen as a last resort, but more just like a band-aid, because there's such serious potential side effects that could occur just because we don't know. And yeah, lastly, it shouldn't be seen as like, oh yeah, we can wait and see what happens in 50 years if we get to that point and then use this as a final solution. But it's just something that scientists are starting to think about and get serious about, because I mean, I think it's a really cool idea, and it could have some serious benefits. So.
Thank you. Any questions for Andrew?
Yeah.
Wait, you said that the sulfate aerosols like will block the solar radiation from like coming to Earth. It'll just reflect it like in the atmosphere. How will that affect photosynthesis, or do you know?
I mean, I think it will affect photosynthesis, but it's just 1% of the sunlight being reflected. So I mean, still a ton of sunlight is getting in. So I don't think. I mean, they've talked about that before. Like, they don't really know what would happen, but I think minimal kind of changes to photosynthesis would happen, but then again, like I don't know because none of it's really been put into action. So it's just kind of one of those unknowns that people don't really know about.
The science and all this stuff is really cool because it's like they do this computer modeling, and they project using basically these really complicated equations. They project what kinds of repercussions these kinds of things might have, and that goes for all, not just what Andrew's talking about, but when they try to anticipate what sort of CO2, what levels of CO2 will be in the atmosphere, or even, like Bryce has been looking at the World Cup question, and they've been able to predict using, again, these computer modeling techniques, been able to predict just about how much CO2 is, metric tons of CO2 is going to go into the atmosphere based on that one event in June and July this year. So it's really cool, like mathematical applications. So, yeah. All right, thanks Andrew, good work. Let's go to our